So what you see here is what you have. This is a 2, this is how much? 3. This is a 5, right? So if this hit this, in which direction this move? Negative. So have to be negative. There's no way that can be possible. Let's see. Oh, they want the initial speed. Have to be negative?
No, the initial speed positive.
Oh, sorry. My bad. Yes, the initial. They don't want the final. Okay.
Yeah.
Find the final. Find the final also. So now you can substitute and find the final, right? The final of B1. The final of B1.
So it should be negative.
That should be negative. Hmm? So you got it? I'll now check the answer. The answer is there?
For the initial speed.
Yes. Is the answer?
Yeah.
And it's right?
Yeah.
Good. So this is the way that elastic collision works. So you basically set up these two equations, and you solve the system of equations, algebra. Good. The next topic is collision in 2 dimensions. So we finished with elastic collision. Collision in 2 dimensions. I will teach just theoretically. You have only one problem here, and it's very simple because it's very tedious. I tend to not put too many questions here and to not put too many questions in the test. It's very tedious. It's in the sense that it's a lot of angles and all this, and the 2 dimensions, so and the calculation is very tedious. And you are in physics with calculus. That's not the idea, that you solve algebra questions. So the momentum in two dimensions, you just need to set up the equation for momentum along x. Momentum along x conserved. So in 2 dimensions, like when you are playing pool, right? There you apply the concept of linear momentum because you have a ball and a target ball, right? The Q and the target ball hit at different angles at a glance collision, not head-on, but glance, and they go in different directions. Have you seen that? This is the linear momentum in 2 dimensions. So the momentum conserved along x and the momentum conserved along y. Final, sorry, x final and x initial. So, since the momentum conserved along x and along y, final along y. Okay, so you will set up the equation like this. The momentum N1 V1 x plus, not vector, just the component, plus N2 V2x equal N1 V1 x. Actually, this is u before the collision. V N2 V2x. The same will be for y. N1 u1 y plus N2 u2y equal N1 V1y plus N2 V2y. And what will be V1x? If it's given the angle and the magnitude of the velocity, how can you replace this V1x? V cosine, but you need to look at the quadrant. So let's say, for instance, if I give this pool table and I give this ball hitting this target ball, this is the 1 and this is the 2. At a glance collision, maybe this will go this way and this will go the 1. Let's say this is the 2 and the 1 will go this way after the collision. So this is before the collision and this is after the collision. This is 2, and this is 1. 1 is at an angle here, going with respect to here, let's say 30 degrees. This is a 45 degrees. This is at rest, and this is going at let's say 25 degrees. Let's say. So you set up a diagram like this to recognize the angle. So what will be N1, U1x? So since it's going, in which quadrant is this? Along x. 1, 2, 3, 4. So the x component will be positive or negative? Positive. So you will say positive N1, the velocity that I will give U1, right? Cosine of 45, plus, what is this velocity? Is this moving? What did I say that it is? It's a target. So if it's a target, what will be? 0 equal, now N1, and this is in which quadrant? In the third. If it's in the third, what will be this? Negative N1. So when we put the V1, will be negative N1 V1 cosine of this angle. Whatever this angle, 30 degrees. Then plus, what will be N2? This will be positive or negative? Positive. Can you see? The same for Y. This is 0. This is N1, U1, Y. This Y is positive or negative? Negative, because it's in this quadrant. And this, negative. And this, positive. And you set up the system of equations, and you will need to solve for 2 equations. Will be very tedious. So if there is one question there, is in straight angles, which is very simple. In the study guide, I put one, I think, that is in a straight angle. Okay? It's not like a... And that question is question number in 2 dimensions. What is the question? Well, we have x and y. 14 is a center of mass. That's what I will teach now, just to finish the lecture. 15. Can you see that 15 is an x and y direction? So you just need to get the momentum along x, the momentum along y, and figure it out what you need to figure it out. This is easy because it's 90 degrees, first of all. And the second thing is because the 2 objects stick together after the collision. So if you get the velocity along x after the collision and the velocity along y after the collision, how can you get the total speed? The square root of vx squared plus vy squared. And if you need to get the kinetic energy of the assembly, actually no, 15 is center of mass. Yes, it's the same. Yeah, it's the same thing. Yeah. But it's also center of mass. So in 2 dimensions, actually, I don't see much there. I think problem 13. Problem 13. That's the one that I was talking about, 13. The final topic is center of mass. How to locate the center of mass and how to locate the velocity of the center of mass of a system of particles. And if it's a continuous distribution, how to find the center of mass. All right. And that's the last topic in linear momentum. So, in linear momentum, we study the definition of linear momentum, the Newton laws in terms of linear momentum, the impulse momentum theorem, which is the area under the curve on the graph F versus T, and mv final minus v initial, that's the impulse. The law of conservation of linear momentum, collision, the inelastic and the elastic. In the inelastic, we study when the 2 objects stick together, or ballistic pendulum, generally speaking, and elastic when you get the 2 velocity after the collision using the simultaneous equation, right? Momentum in 2 dimensions was more like to understand how to set up the equation for momentum in 2 dimensions. As I said, not much in the test. If there is in the test, it will be question like the question that is here, which is very simple. You try to do it, and we will go over that in the next class. Finally, a topic that is very simple is center of mass and how to locate the center of mass of a system of particles. Center of mass. Let's say that I give a symmetric body. For example, I give a sphere. Where do you think that will be located? Uniformly distributed. So the density is the same. Density is uniform. Where will be the location of the center of mass of that object? At the center. Right? So if it's a symmetric body, where will be the location of the center of mass? In the center. This is if we have a uniform distribution. It is a system of discrete particles. Discrete particle means that you can see individually. For example, this is a continuous distribution because we cannot see the particles individually. But if we have a system where we have M1, M2, M3, M4, we can locate the center of mass of that system. So the center of mass of that system with respect to this point or with respect to this point will be the same. Doesn't matter with respect to what point the center of mass will be located in the same place. So if you have that this mass is bigger based on the size, where do you think that will be located the center of mass of that system of particles? Closer to which particle? So to M2, if based on the size is bigger, so the center of mass will be more located to this side maybe, you know, like this, something like that. How can we find it? Very simple. So to locate X center of mass, the location of the center of mass along X will be the summation of each product of the mass and the position divided by the summation of each mass. That's how to locate the center of mass. Why? How can we find YCM? Again, this is the same than M1 X1 plus M2 X2 plus Mn Xn over the entire mass, which is the summation of all masses. M1 plus M2 plus M3 then we have this Ni Yi divided by the summation of each mass. This is how to locate the center of mass on the y-axis. What will be the total position of the center of mass as a vector? RCM, which is XCM I plus YCM J. And that's the position of the center of mass in IJK notation. Okay, how to get the velocity of the center of mass? The same thing. Velocity of the center of mass along X will be the summation of MIBI along X over the total mass, which I can put capital N, the mass of the entire system, the summation of each mass, or BCMY equal the summation of MIBI Y over the entire mass. This is basically the idea of the center of mass. Example. Now, this is not a uniform distribution. If it's a uniform distribution, to get R, Cm will be 1 over M, the integral of M x dm. And we need to change this to a spatial coordinate and so on. So I want where dm will be lambda d